When you upload a file and see "Upload successful," your brain assumes the data is permanently stored. But that's an illusion. What actually happened is this. Your client sent data, the server received it, and returned a 200 OK acknowledgement. That acknowledgement only confirms receipt, not durability. Between receiving data and actually persisting it to disk, there exists a hidden failure window. If the system crashes in that gap, your data is gone. Success at the protocol level does not imply success at the storage level. HTTP 200 OK only means the server successfully processed the request at the application layer. It may have parsed the file, validated metadata, and queued a write operation. But critically, the acknowledgement can be sent before the data is flushed to disk. Many high-performance systems optimize for latency by responding early. The write might still be buffered in memory, waiting for disk I/O. If power fails or the process crashes before persistence completes, the client believes success occurred, but no durable state exists. Between memory and disk lies the failure boundary. When a server receives data, it often stores it temporarily in RAM. Writing to disk is slower, so it may happen asynchronously. If the system crashes during that interval, everything in memory is lost. Mesh or RAM is volatile. Disk is durable. That boundary between volatile and persistent storage is where reliability is decided. Acknowledgement before crossing that boundary is an architectural risk. Understanding this boundary is fundamental to distributed systems design. Even writing to disk isn't always truly durable. When an application performs a write, the operating system often stores it in a page cache, memory managed by the OS. The system may report the write as successful, even though it hasn't reached the physical disk platter or SSD cells. Only a forced flush operation, like fsync, guarantees durability. Without that flush, a sudden power loss can wipe the data. So durability requires crossing not just application boundaries, but operating system level buffering as well. In distributed systems, the problem compounds. A primary node might acknowledge the write before replicas receive the data. If the primary crashes before replication completes, the cluster can lose the latest update. This is why systems define write concerns and replication guarantees. Acknowledgement might mean written locally, but not replicated safely. Durability in distributed systems requires consensus, not just receipt. The difference between single-node durability and distributed durability defines real-world reliability. Durability exists in levels. The lowest level is in-memory acknowledgement, fastest but fragile. Next is local disk persistence, durable against process crashes but vulnerable to hardware failure. Higher still is replication across nodes. The strongest level is quorum commitment, where a majority confirms the write. Each level increases latency, but improves reliability. Engineering is about choosing the correct durability guarantee for your workload. Speed and safety exist in tension. You must explicitly choose your trade-off. Industrial-grade systems handle this explicitly. Cloud Object Storage replicates data across multiple availability zones before confirming durability. Databases allow configuration of write concern levels. Some guarantee commit only after journal flush and replica acknowledgement. These systems define durability contracts in their API. When they say stored, it has a formal meaning backed by replication and persistence guarantees. Reliable systems don't rely on optimism. They define and enforce failure boundaries. The core invariant is simple but powerful. Acknowledgement does not equal durability. Every system has a failure window between receipt and persistent commitment. Your job as an engineer is to identify that boundary, minimize the window, and define what success truly means. Whether you're building file uploads, databases, or distributed platforms, durability must be intentional. Reliability is not a side effect. It is a design decision. If you do not define your durability contract, your system will define it for you under failure. That's all for today. Make sure to subscribe and comment for which topic you want to learn next. Peace out.